This question addressed the key topic of trig graph transformations. Now, when we covered this topic in class, there were 4 big transformations that we focused on linking to the trig graphs. If you look here, these are given by the A, B, C and D in each of these equations. Now, sine and cosine tend to be the most commonly used, hence the reason only these 2 are here. However, the transformations still apply to the tan graph, so don't rule it out completely. Now, the A focuses on the amplitude or the magnitude, i.e. the size of the graph. So what it does is it stretches or squashes it in the y direction. If the size of A is bigger than 1, it stretches it in the y direction. If the size of A is less than 1, so between 0 and 1, it squashes it in the y direction. Now, I haven't mentioned negative numbers there. If we get a negative number in front of it, what that does is it flips the entire graph over the x-axis, so it reflects it around that. So the maxima then switches and becomes a minima, and vice versa. The B reflects what's called the period of the function. The easy way to remember this is this value here, the B, tells you how many times in 360 degrees the graph will repeat itself for sine and cos. For tan, it's how many times in 180 degrees it repeats itself. Using this, we're able to calculate what's called the period of the graph. Now, originally, sine and cosine take 360 degrees to repeat themselves, which means the period of repetition is 360, so the period of the graph is 360 degrees. To change that, what we do is we take the 360 degrees and we divide it by whatever the value of B is, and that then tells us what the period of the graph is. It tells us how long it takes for the graph to repeat itself. The C takes the graph and shifts it left or right along the x-axis. So if we were to add on a number here, so let's say add 45, it would shift it in the x-axis by 45 degrees. However, it acts in the opposite way we would think. So if we add on 45 degrees, instead of actually shifting up in the positive direction of x, it actually shifts it down in the negative direction of x. So the graph in this case would shift that way for a positive value, and that way for a negative value of C. It has that sort of effect on it. And then the D shifts the graph up or down in y. Now this one actually follows what you'd think. If we add something onto the graph, the whole thing's going to move up. If we subtract something from it, the whole graph is going to move down. Now we have to look at these, figure out which of these has had an effect on the graph that we want here, and then figure out exactly how it shifted the graph. What we're then able to do is figure out where the new minimum turning point, which is this point A, has shifted to. Now, the key thing we have to remember, it's the cosine graph, so the original turning point is at 180 degrees, negative 1 in the y. So we have to figure out what's happened to it now. So let's look at each of the transformations, because what's happened is we've got a 3 here, and we've got the plus 45 here, so they're the 2 transformations that have happened. So the 3 in front of it, this has changed the amplitude of the graph. So this has followed the transformation given by A. Now we said if the size of A was bigger than 1, what's happened is it's stretched every single point of the graph by that amount. So in order to figure it out, all we would have to do is multiply the y part of the coordinate by 3. So for the coordinate of A, we already know that the negative 1 has stretched down to negative 3. So we already know how far down in y this is now moved. What we then have to do is look at the next part. The next part is given by this plus 45 here, which is the transformation referred to by C in the original equation. Now we've said what this does is it shifts it left or right along x, but it goes the opposite direction to what we'd assume. So we've added 45 degrees, so what that actually is going to do is shift it left by 45 degrees. So it's going to shift the x part of the coordinate down 45 degrees. So in order to get that, we do 180 and we take away the 45. So 180 take away 45 gives me an x part of my turning point of 135 degrees. So that there is now where the turning point of the graph is shifted to when we've done this transformation here. We have to remember how all four of these work and how all four of these affect the graph. It's important to know what each transformation does, how each transformation modifies the graph, and how we can relate this to the key points of the graphs. So that's the parts where it cuts the axes in both the x and the y, and the turning points, the maximum and minimum turning points of the graph. We've got to be able to say how these have moved and where their new coordinate is located at.